Hey folks, this is the lesson video for section 6.2. If you remember from last week, we started working on this little worksheet called Finding the Numbers. You're going to find this in your My Lab under the course worksheets. This is the same place that we go every single time that we're in class together. So this is no different from what we would be doing in class. Now we actually started on this worksheet, but I wanted to just go back and remind you of what it was like. So I want to do just a few of these. I'm going to do number 10 and number 18 on the first page, and then I'll do a couple more on the second page. So let's look at number 10. Remember that what you're doing here is you are, read the directions. For each problem below, find a pair of numbers that are going to solve both equations. In class, I told you always, always, always work with the product first. So we want to deal with the product first. And what you want to do is you want to make a list of all of the factors that could be this number. Remember, factors are things that you multiply together. So, for instance, one pair that would multiply to give you a 72 would be the number 1 times 72. So what I want you to do is I want you to pause the video and I want you to think about all of the pairs of numbers that will multiply to give you the number 72. So go ahead and pause the video right this moment and make a list. Okay, now that you're back, hopefully you've got a list of factors. There's 6 pairs of factors that could give you the number 72. And so then the next question that you're going to ask yourself is which of these pairs will add, so now we're going over to the second piece of this, which of these pairs will add to give you the number 17? Which pair will add to give you the number 17? And hopefully you can see here that there's only one pair of numbers that will give you the number 17, and that's going to be the 8 and the 9. So we know that 8 times 9 is 72. We also know that 8 plus 9 is 17. Now let's do the same thing for example number 18. So again, pause the video and make a list of all of the pairs of numbers, all of the pairs of factors that would multiply to give you the number 36. Okay, now that you're back, you should have gotten a list of 5 pairs of factors. So these are the numbers that multiply to give you 36. I want the one pair of numbers that will add to give you 13. So which pair of numbers would give you 13? Only the 4 and the 9 is the one pair that would give you a 13. So we have 4 times 9 will give you 36, but not only that, 4 plus 9 will also give you 13. Now let's step it up a notch. This time, I'm going to throw in some positives and negatives, but my questions are exactly the same as they were for the first part of this. So you see here that I've got 2 numbers I want to multiply together to give me negative 35. Now, for the moment, just ignore the negatives. Just pretend that this is the number 35 and do exactly what you did from the first sheet. So I want you to pause and list for me all of the pairs of numbers that will give you 35 when they're multiplied together. Okay, now that you're back, you should have only gotten 2 pairs, 1 times 35 and 5 times 7. Now, for the next part of this question, this piece is going to change a little bit. I want to know not only which of these pairs will add to give me a 2, I want to know which will add or subtract to give me a 2. And so my second part of the question now is just a little bit different than it was on the first page. So which pair will add or subtract to make a negative 2? Well, we know that that's going to be the 5 and the 7 pair. All right, so let's do this. Let's put 5 and 7 in the blanks. We're still not worrying about the pauses and the negs. So we have a 5 here and a 7 here, same over here. But we know that 5 plus 7 does not equal negative 2. So where would I need to put in a negative so that a 5 and a 7 could give me a negative 2 when I'm adding or subtracting? Well, that would be correct. My 7 would need to be negative, so that now a 5 plus a negative 7 gives me a negative 2. So I'm going to do the exact same thing over for the multiplying part of this. Right now, 5 times 7 doesn't equal negative 35. It equals positive 35. We want to put that negative on the 7, just like we did in the first pair. And 5 times negative 7 will give me negative 35. All right, let's do another pair. So what two numbers could multiply together to give me a 28? Again, right now I'm not too worried about the pauses and the negs. Okay, so you should have come up with 3 pairs of numbers, 1 times 28, 2 times 14, 4 times 7. Now, I want the pair that when added or subtracted could give me a negative 3. And I can see then that this is going to be the 4 and the 7 pair. Now, before we write it down, when I write down a 4 plus a 7, that's not equal to negative 3. And so I don't want just 4 plus 7. It would need to be a 4 plus a negative 7. That would give me a negative 3. We'll use the same pair of numbers over here for my product, so that'll be a 4 times a negative 7 to give me a negative 28. All right, one more of these examples. And so let's find a pair of numbers that when I multiply them together, they give me a 12. So go ahead and pause, come up with a list. All right, you should have come up with 3 pairs, 1 times 12, 2 times 6, 3 times 4. Now this time I want the pair of numbers that will either add or subtract to make a negative 7. And I know that there's only one pair, and that's going to be the 3 and the 4 pair. All right, so 3 plus 4 is not negative 7. 3 plus 4 is positive 7. So where do I need to put some negatives to make this a true statement? I want both a negative 3 and a negative 4. When I say negative 3 plus negative 4, that's the same thing as negative 7. All right, let's use the same pair of numbers for my product. Negative 3 times negative 4, and negative 3 times negative 4 really is a positive 12. So that's kind of going to set you up for the factoring that we're going to do next. So this is the section 6.2 worksheet, as I noted before. And the first thing that you want to ask yourself is a question that we learned about back in section 6.1. Is there a GCF? And so we'll be asking that question as we go along. Notice that my directions say that I should factor. Factor is basically the same thing as unfoiling. Back in chapter 5, we learned how to foil. First, outer, inner, last. You remember that. And now what I'm trying to do is I want to undo that. I want to unfoil. But the real mathematical name for that is factoring. So I'm going to use some concepts like what I just learned about in the 2 worksheets that we just went through that we also touched on last class period. Notice number 6 here. Is there any GCF? Well, when I look at all 3 terms, it does not have anything that's common in all 3 terms. There's some things that are common in the first 2 terms, some things that are common in the second and the third term, but nothing to all 3 terms. So this does not have a GCF. Remember that with foiling, we always had 2 binomials that were being multiplied together. So let's go ahead and set up our empty set of binomials. And now I'm going to ask you about multiplying. What 2 things multiply together to give you a 25? Well, you could say a 1 times a 25 would work, or you could say that a 5 times a 5 would also work. Okay, but we want the pair that is going to give me a 10 in the middle by adding or subtracting. So let me repeat what I just did. This is just like that worksheet we just went through. I want 2 numbers that'll multiply to give me a 25, but that will add or subtract to give me a 10. And so the pair that I want to use for this is going to be the 2 5s. These are going to be my lasts. Now, how do I get my firsts? Well, go to the very first term and ask yourself what 2 things would multiply to give you an x squared. And that would be an x and an x. X times x is x squared. All right, now let's go back and deal with our signs. Remember, we wanted two numbers that will multiply to give 25, but that will add or subtract to give a 10. Let's investigate a little further. Not only do I want just a 10, I want a negative 10. So how can these two 5s add or subtract to give me a negative 10? Well, they would both need to be negative. Now, there is always, always, always a way to check your work. Just FOIL. If you FOIL, you can check your work. So take a look. What are the firsts? The first are x squared. What are the outers? That's a negative 5x. What about the inners? That's a negative 5x. And what about the lasts? Negative 5 times negative 5 is a positive 25. Now combine your like terms and ask yourself, did you come up with the exact same thing that you had to begin with? Yes, you did. Now this foiling, I'm going to erase this. This was just a way to check my work. That's not part of my answer. But this is now factored. Now, I want to say one more thing about this question. Notice that both of these factors are identical to each other. I could actually write this as x minus 5, the whole entire quantity squared, because that square means that the x minus 5 was duplicated. I had two of them. All right, let's go across to number 14. This one looks a little funky. So let's set up our two binomials. Now, before we do that, I'm sorry, I jumped the gun here a little bit. Do I have a GCF for all three terms? Something in common for all three terms? Well, no, I do not have anything in common for all three terms. So there's no GCF. Let's just jump right on in. So ask yourself, what things can be multiplied together to give you an x squared? And we would say an x and an x. Next, go to the end and ask yourself the same question. What things can be multiplied together to give you an 8y squared? Now, I know this is going to be a y and a y. Just deal with the 8 the same way that we dealt with it a moment ago in that worksheet. I could have a 1 times an 8. I could have a 2 times a 4. Those are the only options. Which pair of options will give me that 6 that I want in the middle if I add or subtract? So I'm going to choose the 2 and the 4 pair. These are going to be on my y's. Okay, now let's take that one step further. I want my 2 and my 4 to be added or subtracted to give me a positive 6. How can 2 and 4 be added or subtracted to give a positive 6? And that will only work if they're both positive. Now I want you to pause the video and I want you to FOIL to check your work. If you FOIL correctly, you should get the original trinomial that we had to begin with. All right, let's jump down to number 16. Once again, ask yourself, do you have a GCF? Is there anything that is common to all three terms? And we would answer that, no, there is no GCF here. So let's go ahead and set up our two binomials. Ask yourself, what two things can be multiplied together to give you a y to the fourth? This one's a little different. And we would say a y squared times a y squared could give me a y to the fourth. Now go to the end and ask what two things could multiply together to give me a 70. So let's make a list of factors. We could have a 1 times a 70, a 2 times a 35. 3 does not go in. 4 does not go in. We could have a 5 times, oh dear, I don't know my 70 times tables. 5 goes into 7 once. With a 2 left over, 5 goes into 20 5 times. I'm sorry, 5 goes into 20 4 times. I apologize about that. So that's going to be a 14 there. 6 does not go in. 7 does go in though, 7 times 10. And I believe that's my last pair unless you start trading your values. All right, so which pair would add or subtract to give you a 3? which pair adds or subtracts to give you a 3? And we can see pretty easily that that's going to be the 7 and the 10 pair. So we're going to put in here a 7 and a 10, but let's take that a step further. What do I have to do to a 7 and a 10 to add or subtract, not just to get a 3, but a negative 3? Well, I would definitely need to have one positive and one negative, and my larger value needs to be the negative. So I would need a negative on my 10, and I would need a positive on my 7. Now I want you to pause the video, and I want you to FOIL these two binomials to tell me whether or not you get the same thing as the original. Let's jump on over to number 22. Is there a GCF with all three terms? No, there's not. So let's set up our two binomials. What two things will multiply together to give you an a squared? We will have an a and an a. What two things will multiply together to give you an 18b squared? Now, for the time being, we know that a b and a b will give us that 18. Sorry, that really is a b. It's not a 6. Now let's go with the number part of this, just the 18 piece, and let's come up with a list of numbers, a list of factors that will multiply to give me 18. We have a 1 times an 18, a 2 times a 9, a 3 times a 6, and that's all of the factors that we will have. So which pair will add or subtract to give me a negative 9? All right, so you should be able to tell that the 3 and the 6 is the pair I want. So I'm going to have a 3 and a 6. Now, not only do I just need to add or subtract to give a positive 9, I need a negative 9. So what do I do with my 3 and my 6 to add or subtract to give me a negative 9? They would both need to be negative. A negative 3 and a negative 6 will give me a negative 9. So once again, pause the video, FOIL these two binomials, and tell me whether or not you got the same thing as the original number 22. All right, several here that are left. Let's go to number 24. Ask yourself once again, do you have a GCF in all three terms? Something that's common in all three terms. Oh, this time I have a GCF. Notice that all three terms have a common factor of 3. So I can factor out a 3 from all three terms. Remember that you factor by division. So if you take 3x squared and divide a 3, you're left with an x squared. Remember, this is last week's lesson. If you take a positive 30x and you divide out a 3, you're going to have a positive 10x remaining. And lastly, if you have a positive 63 and you divide out a 3, that's going to be a positive 21. Now, I factored out the GCF just like I did last week, but I believe that there's some more factoring that we can possibly do here. We can factor the way that we just learned, the unfoiling method. Now, don't forget that the 3 is still there. You're not going to do anything with it. You're finished working with that one. But let's separate the next trinomial into two binomials. And we're going to work with just this piece for the time being. So once again, ask yourself what two things can multiply together to give you an x squared. You know that that's going to be an x and an x. And then ask yourself what two things can multiply together to give you a 21. And so let's make a list of factors. You could have a 1 times a 21, or you could have a 3 times 7. And those are the only possible options that you have for factors. Well, we have 3 and 7 that could also add or subtract to give you a 10. So let's choose that pair of numbers. How can I combine a 3 and a 7 to give me a positive 10? Well, the 3 and the 7 would both need to be positive. Now, what you could do to check your work on this one is that you could go ahead and FOIL these two, get a trinomial. In fact, it should give you this trinomial if you FOIL that out. and then take that trinomial and you could distribute the 3. If you distribute that 3 correctly, you should get the original trinomial that we started with. So you can work your way backwards to check your work. Let's look at number 26. Again, is there a GCF? Is there something in common with all 3 terms? It looks to me like I have a 3 in common, but wait, there's more. There's not only a 3 in common with all 3 of these terms, there's also an x in common with all 3 of these terms. So let's start our factoring. So you want to take your first term, 3x cubed, 3x to the 3rd power, divide your 3x. Okay, so the 3 divided by the 3, that's the 1. And x cubed divided by x is going to be an x squared. Then the next thing you want to do, take your negative 12x squared and divide your 3x. Well, a negative divided by a positive is going to be a negative. Your 12 divided by your 3 is going to be a 4. And your x squared divided by your x is going to be an x. All right, let's do the last term. What is negative 36x divided by 3x? Well, negative divided by positive, once again, is negative. 36 divided by 3 is 12. And last, x divided by x is 1, and I don't need to write down that 1. This is looking good so far. So now let's continue with our factoring. We factored out a GCF, that was the 3x, but it also looks like my trinomial can be factored further. So ask yourself, what 2 things can multiply together to give you x squared? And we know that's going to be an x and an x. Then ask yourself, what 2 things can be multiplied together to give a 12? Well, that's either going to be a 1 times a 12, a 2 times a 6, or a 3 times a 4. Which pair of numbers will now add or subtract to give you a 4? And the only pair of numbers that will work with is the 2 and the 6. So let's go ahead and put those in. Now, don't get hung up on this. I need the 2 and the 6 to either add or subtract to give me a negative 4. How can I add or subtract a 2 and a 6 to give me a negative 4? Well, I would need a positive on my 2 and a negative on my 6. I want you to pause the video, and I want you first of all to FOIL these 2. If you FOIL those 2, you should get this trinomial. After you FOIL that, you should be able to distribute the 3x. If you distribute correctly, that should give you the original trinomial that we had for number 26. Moving on, number 34. This one doesn't look too hard. Do I have a GCF? I do not have a GCF for all 3 terms, so we'll just start with our 2 binomials. Ask yourself what 2 things can multiply together to give you an r squared, and you'll get an r and an r. Then ask yourself what 2 things can multiply together to give you a 21. Well, we could have a 1 times a 21 or a 3 times a 7. Those are our only options. If you use the 3 and the 7, it'll give you a 10 in the middle. It will add or subtract to give you that 10. But wait, we don't just need a 10, we need a negative 10. So how can you combine a 3 and a 7 to give you a negative 10? Well, we've got our 3 and our 7. If they were both negative, they would give you a negative 10. Please pause the video, FOIL these 2 out to make sure that we factored correctly. Let's jump on over to number 44. There's no GCF with all 3 terms, so let's go ahead and make our 2 binomials. What multiplies together to give you an x squared? X and x. What multiplies together to give you a 10? We have a 1 times a 10 or a 2 times a 5. Those are our only options. And you ask, well, which pair of options here, or excuse me, yes, which option pair would give you a 4 when you add or subtract? And you think, she's trying to trick us. Neither option gives a 4. Folks, every once in a while, you're going to run into a trinomial that cannot be factored. when a trinomial cannot be factored, we say that it is prime. Now, please understand, this is rare. This does not happen very often. Take a look at how many we have factored so far, and this is the first time that this has happened. So 1, 2, 3, 4 on this screen, 5, 6 on that screen, 7. This is the 8th question we've done, and only 1 out of the 8 is not factorable. So just understand, this does not happen often. All right, let's take a look at number 50. Do we have a GCF on all 3 terms on number 50? Well, it looks like we do. We have a 3 that is common to all 3 terms, but not only that, we also have a y that is common to all 3 terms. So let's factor out the GCF first, and then we'll decide whether or not to factor the continuing trinomial. So let's look at the first term first. 3x squared y. You want to divide out a 3 and a y. So what's left over when you take these 3 pieces and divide out a 3y? Well, when you just divide the numbers, the 3 divided by the 3, those go away. When you divide the y's, those go away. The only thing that's left over is an x squared. Now let's take the middle term. Negative divided by a positive is going to be a negative. 9 divided by 3 is going to be a 3. The y divided by the y, those will cancel out. The only thing left over is the x. Last term. A positive divided by a positive is going to be positive. A 45 divided by a 3 is going to be 15. And a y divided by a y will cancel out. All right, so this is starting to look normal. Let's see if our trinomial can be factored any further. So go ahead and copy down your GCF. We don't want to forget about it. And let's see if we can break this trinomial into 2 binomials. So the first question, what multiplies together to give you x squared? Well, you know that's going to be an x and an x. Second question, what multiplies together to give you a 15? Well, we could have a 1 times a 15. We could have a 3 times a 5. And that's all we have. Neither of those pairs is going to add or subtract to give you a 3 in the middle, no matter how you try. So there's no way that I can go any further. Now, my answer here is not prime. I was able to factor. I just was not able to factor my trinomial further into 2 binomials. So at that point then, we would say that this first factored piece where I factored out the GCF, that is my final answer. That is factored as far as I can go. Let's jump on over to number 52. There's no GCF with all 3 terms. So let's go ahead and set up 2 binomials to see if we can factor out. So let's look at, first of all, our what 2 things multiply together to give x squared, and that's going to be an x and an x. And then what 2 things multiply together to give me a 32? Well, I could have a 1 times a 32. I could have a 2 times a 16. 3 does not go in. I could have a 4 times an 8. 5 does not go in, 6 does not go in, 7 does not go in. Now I've hit the 8 again, so I'm finished with my factors. There's 3 pairs of factors. Do any of these factors add or subtract to give you your 4 in the middle? And we can see that the 4 and the 8 is something that might work. And so we have a 4 and an 8. Now, make sure that we have... I'm sorry about that. Make sure that when we add or subtract to get our -4, that we do this properly. So if I have a positive on my 4 and a negative on my 8, then I would get a -4 when I add or subtract. Please take a minute to pause the video. Go ahead and FOIL these 2. And make sure that you actually get what we had in number 52 to begin with. All right, let's go to number 58. Do I have a GCF for all three terms? And yes, it looks like I do. Looks like I've got an x that's common to all three terms. So let's divide the x out. If you take x cubed and divide x, you're going to get an x squared. If you take a negative 3x squared and divide x, you're going to get a negative 3x. And then lastly, if you take a negative 28x and divide out an x, you will get a negative 28. All right, let's take the time to see if we can factor our trinomial into two binomials. What multiplies together to give x squared, x, and x? What multiplies together to give 28? Well, let's see what our pairs are. You have a 1 times a 28, a 2 times a 14. 3 does not go in. 4 goes in, 4 times 7. And that's the last pair. 5 doesn't go in, 6 doesn't go in. It appears that the 4 and the 7 could add or subtract to give us that 3. So let's find out. If I have a 4 and a 7, what signs would I need on the 4 and the 7 to make a negative 3? Well, I would need a positive on my 4 and I would need a negative on my 7. Now take a minute. I want you to pause the video. I want you to FOIL, please. When you FOIL, do you get this trinomial that we had right here? You should. And then take your trinomial and multiply by the GCF. Just use distribution on that. And you should get the original from number 58. All right, let's look at number 60. Do I have a GCF on all three terms? I do. I have a number GCF, there's a 3, but I also have a variable. I've got 4 x's that are common to all three terms. So let's take out a 3 and an x to the 4th for all three terms. When you take out the 3, when you divide by the 3, those cancel. When you take x to the 6th divided by x to the 4th, you're going to get an x squared. When you have a positive 30x to the 5th and you divide 3x to the 4th, that's going to give you a positive 10x. And last but not least, when you have a positive 72x to the 4th divided by a positive 3x to the 4th, that's going to give you a positive 72 divided 3 is 24. X to the 4th divided by x to the 4th is going to cancel out. All right, so keep your GCF there. Let's copy it down and let's see if our trinomial will factor into two binomials. So what two numbers multiply to give you x squared? An x and an x. What two numbers multiply to give you a 24 at the same time as giving you a 10 in the middle by adding or subtracting? So 24, you could use a 1 times a 24. You could use a 2 times a 12. That looks like it might be a good option. You could use a 3 times an 8. You could use a 4 times a 6. Oh my goodness. I have a second option that looks like a possibility. So let's take a look. 2 and 12 could subtract to give you a positive 10. And 4 and 6 could add to give you a positive 10. So this is the first time that we've ever run into two possibilities for this. So what we're going to do is let's just go ahead and try it out. Now let's take a look. If I chose the 2 and the 12 option, by the way, you might not want to write this one down because it's going to be wrong. If you chose the 2 and the 12 option, we would need a negative on the 2 and a positive on the 12 just to give me that positive 10 in the middle. But wait, if you start to FOIL, you're going to find that this works out just fine for the firsts, the outers, and the inners. But if you take your lasts and you multiply those together, you do not get a positive 24, you get a negative 24. So then I don't want this option of numbers, so let's go ahead and erase that option, and let's go back and try our adding option, the 4 and the 6. All right, let's try it again. If I have a pause on the 4 and a pause on the 6, that's going to give me a positive 10 when I'm adding. Let's check out our foiling. The first, the outers, and the inners will all work out just fine. Let's look at multiplying those last. Is a positive 4 times a positive 6 really a positive 24? And absolutely, yes, it is. This is the pair that we want to stick with. Notice I would never have caught that mistake unless I was checking my answer by foiling. So once again, make sure that you always check your answer by running a FOIL check really quickly.